Hi everyone, I'm going to give you a brief introduction to the periodic table and its elements. So currently there are 118 elements that are known, and 88 of these elements are naturally occurring, and those are the ones that you're mostly going to need to be concerned with in this course, the naturally occurring ones. And even if you look at the Earth's crust, oceans, and atmosphere, so basically our Earth, most of our Earth is actually made from oxygen. That's about 49.2%. And silicon is about 25.7%. And silicon is actually a really cool element. You think of like going to the beach in the sand or the desert in the sand, that's silicon. We make our a lot of the solar panels that we use to get solar energy out of silicon, and so you can see it's a very abundant element, and that is why it is so appealing to use for making energy. And then you can see pretty much everything else is not very abundant here on Earth. We have 7.5% aluminum, iron is 4.7, calcium 3.4, sodium is 2.6. You have potassium at 2.4, magnesium is 1.9, and then after that, everything is point something. So hydrogen, titanium, all these other elements are not very abundant on our Earth. And interestingly, our body is also primarily composed of oxygen as well. It's about 65% of our body is from oxygen, and that's the human body. 18% carbon and 10% hydrogen, and then everything else is just a little percentage. So we're mainly made out of just 3 elements. So even though we have 88 naturally occurring elements and the rest are made in the laboratory, out of those 88 elements we don't really use as many abundantly or in a high percentage as you might expect. So the periodic table arranges all of the elements in a way that the elements are actually organized by similar reactivities, similar properties, so it's actually very convenient. And so basically there's a way to read the periodic table. It's just like reading a book. It's from left to right. You read the periodic table going 1, 2, 3, 4, 5, 6, like you just go from left to right, then back to the beginning, left to right. And each row is called a period. And you'll notice that there's actually 7 rows total. And you can also read the periodic table going down. And when you go down, these are called columns, groups, and they're also even called families. And actually when you go down the periodic table, each column and each element in the column are really closely related in terms of their properties. So going down a column is more of a predictive factor to how an element is like than going across. So for example, if you were to look at, you would expect lithium, right here Li is lithium, and you'd expect sodium, Na here, these 2 elements, you'd expect them to react very similarly, to have very similar properties compared rather than say lithium compared to beryllium here. The other characterization we give for the periodic table, these yellow sections, these yellow columns here are your main group elements. These ones usually have very easy to predict characteristics. While in the middle, these blue section here, these are your transition elements. These are less predictable. The properties tend to be less predictable. The other thing that you should know about the periodic table is that it is arranged by atomic numbers. So you can see that's given here on the top. Here's the atomic number. That's the chemical symbol, and you have the atomic mass. So you're looking at the top atomic number on top, which we'll get into later, but that's basically the protons. But just know that's the atomic number. If you don't know what protons are yet, we'll talk about it later. But if you look, hydrogen is 1, helium-2, then lithium-3, beryllium-4, boron-5, carbon-6, nitrogen-7, oxygen-8, and so forth. The other thing that's interesting is that not only are they arranged by properties, having similar properties, by their, let me go back, by their atomic number, which also is indicative of their size, right? They keep getting bigger as you go down. What you also find is that it's also arranged by being a metal or a non-metal. So everything basically to the left of the periodic table is a metal. That includes the transition elements or the transition metals, and the main group elements in column 1 and 2 are all metals. Everything pretty much on the left hand side are non-metals, and then you have this blue area, right? That blue area right here is actually, it's actually green on this periodic table. These are called metalloids. So these metalloids are not quite metals and not quite non-metals. So their properties are in between the two. So for example, metals are hard, shiny, malleable. They conduct electricity like you think of with aluminum, copper. And non-metals, they are typically gases like oxygen, fluorine, chlorine. Nitrogen, they're typically gases, helium. And if you look at these guys in the middle, they're not really quite either one of these. They're not really great conductors like metals, and they're not really non-conductors like non-metals. So they're what we call sometimes semiconductors. You can see silicon is here, and that is actually an element that we use for computer chips because it is a semiconductor. All right, now that I've kind of given you a brief overview of the periodic table, and we will come back to it later, I'm going to show you how we represent molecules, right? And that's basically a compound that's made up of elements. So here's carbon and 4 hydrogen connected. We have different ways to represent these elements connected to each other. One way is just a molecular formula, just showing them sitting next to each other. Another way is a structural formula where you just show them connected. So the carbon is connected to the 4 hydrogen here. These are, total of 1, 2, 3, 4, 5 atoms. We can also use ball and stick models and a space filling model. So you'll see potentially all of these throughout the lectures. So many of the nonmetals that we talked about in the periodic table occur as diatomic molecules. And diatomic just means they're made up of 2 atoms. So for example, hydrogen typically in nature is two hydrogens. It doesn't usually float around just by itself. It usually is bound to another hydrogen. Same thing with nitrogen. You have 2 nitrogens or 2 oxygens or 2 chlorines. And a quick, easy memorization for that, one of my students taught me this, is have no fear of ice cold beer. And these are all of your diatomic elements that you should know. So for example, hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. All of these elements occur naturally as diatomic molecules. And the last concept I'm going to quickly go over with you so you can understand what's going on with the lectures is how to name binary compounds, or even how just to read them, what you're reading. So the general idea is you have a prefix and the name of the first element, and then a prefix and the base name of the second element plus "ide". All right, so just to show you the prefixes, like mono is 1, di is 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. And these are some of your common anions. So for example, fluorine, its base name is fluor. So you'd say fluoride, like sodium fluoride. Same thing, chloride, so base name chlor, and then you add that ide. So here's some examples for you. So for example, you can have dinitrogen, so you have 2 nitrogen, di, that's the prefix, nitrogen's the name, and then you have 1 oxygen, so it's monoxide. So you have the plus ide portion of it, and his base name ox. Same thing here, you have 2 phosphorus, so you say diphosphorus, and then this one would be 5 oxygen, so it's pentaoxide. Alright, well that is everything to give you a brief background of naming and the periodic table and how molecules are typically represented. So I know it's a lot in a little short lecture, so I hope it makes sense. Okay, I will see you guys later.